Hello class, today we are going to start talking about regression, and we're going to start with talking about the difference between correlation versus causation. You should have your guided notes to help you go through the PowerPoint. It's going to definitely highlight the most important points that I want to make sure that you get. But again, if there's anything else that you feel that will be helpful to you, make sure you write it down anywhere, either on that particular slide or in the margins. Now, first we're going to talk about what correlation is. It is a statistical way to measure the relationship between two sets of data. It means that both things are observed at the same time. And we're going to have a lot of examples that we're going to talk about. And then causation means that one thing will cause the other. Meaning that because this happened, it caused the other thing to happen. Remember, it's good to pause the video either before or after I talk so that you can listen and then copy and not try to do both at the same time. Alright, you can have correlation without causation. This is important. There's a correlation or relationship between the number of firemen fighting a fire and the size of the fire. So basically, more firefighters at the scene means that there is a bigger fire. However, this doesn't mean that bringing more firemen will cause the size of the fire to increase. So that's where there is correlation, but not necessarily causation. Now let's look at a couple of these and see if it is causation or correlation. A recent study showed that college students were more likely to vote than their peers who were not in school. And that is correlation. Example 2. Dr. Shaw noticed that there was more trash in the hallways after second period than first period. That's correlation. And then, if you look at example 3, you hit your little sister and she cries. Well, she cried because you hit her, so that one would be causation. Alright, now we're going to look at how to measure correlation. When you talk about correlation, it's measured by the correlation coefficient, which is your R. R is always a number between -1 and 1. And there are 4 traits to correlation. We'll talk about the form, the direction, the strength, and the outliers. Okay, and just a little bit about the strength real quick. You'll always have a number between -1 and 1. When you have those two numbers, either -1 or 1, that is the strongest it can be. 0 means that there is no correlation at all. But like I said, we are going to talk about that a little bit more on another slide. Now, form. And again, you should have a slide on your guided notes about this one. So right next to each one of those pictures, you want to write what type of form that has. And so if you look at the top left one, it is linear. And some of these we have not talked a lot about, so I understand you not being familiar with it, but we need to make sure we understand. This next one, top right, is quadratic. And a quadratic is just a U, an upside down U. Or, I mean, not upside down, but a U or upside down when it's both a U, so it's a quadratic. That one is cubic. There's no correlation there. Those dots everywhere does not look like it makes any type of graph, so there's no correlation. And this last one looks like one that we talk about and we sometimes forget about, but it is exponential. Okay. Now we're going to look at the direction. Very easily, direction is just like when we talk about increasing or decreasing or what type of slope it has. So if I'm looking at this one, is it going up or down? It's going up, so it has a positive correlation. And so that means the second one has a negative correlation. And now looking at the strength. And you have to, when you're looking at the strength, it goes from weak to strong. So if I'm looking at these, the ones on the left are weaker until you get to the right. And if you look at those, the difference, you should notice a significant difference. It looks like on the left, the ones they're a little bit more spread out, and then they start coming closer and closer together till they're almost in a perfectly straight line on the right side. So the closer they are into being a perfectly straight line, that is the stronger it is. So it's going to have a stronger correlation coefficient. Now, what that means is that if you look, the closer they are together, the closer I am to 1. Now, for these particular ones, they're all going up and to the right. So because they're all going up, all of those are going to be close to positive 1. Well, if I switch the direction and they were going in from left to right going down, that would still be the same. They would still be getting closer or stronger as we went across, except we would be getting closer to negative 1. So that we need to make sure we understand that. And like I said, we will look at some examples, and also we are going to have some in our classwork. Data that doesn't fit in is what we call outliers. I believe everybody is pretty much familiar with that. So when you have a point that's just far away from everything else. And so in these two situations, the highlighted points are your outliers. All right, now, this is not part of your notes. These are examples. If you want to write those down, feel free to take out a sheet of paper and do that. Remember, this is a video, so you can pause it and go at your pace. If we're put the correlation coefficients in order from weakest to strongest, and I'm going to go ahead and give you a hint. The signs have nothing to do with it being weak or strong. The closer the number is to 0 makes it weak. The further away from 0 makes it stronger, no matter if it's positive or negative. And so if we're putting them in order from weakest to strongest, go ahead and pause the video if you want to take a moment to see. But this will be the order. You will have 700s, 4300s, negative 8100s, 8700s, and then negative 9800s. And if you look at that and ignore the signs, you can see that it's just like putting it in numerical order. And the number that's closest to 0 is 0.07 or 700s. And the one furthest away from 0, closer to 1 or negative 1, is negative 9800s. All right, try example 2 now. Understanding what we know now, we understand we're going to put it in this order. Now, if there's a question, make sure you write it down and ask me, or ask one of your neighbors to explain. Remember, we always encourage discussing stuff with the class, and so you can take that opportunity to do that. All right, if we're looking at this scatter plot, and we're trying to figure out what the correlation coefficient is, meaning, are they really, really close together? Are they really far away where there's absolutely no correlation? Or are they kind of close together? Well, the first thing we have to notice is, does this scatter plot look like it's going up or down? And remember, we'll always look from left to right. And if you're looking from left to right, they look like they're going up. So it cannot be negative 1 or negative 0.5. So if we say that they have some type of correlation, are they really, really, really close together like it would be 1? No, we're not. So our correlation coefficient is approximately 0.5. Okay, on this one, what the first thing you notice is that it's going in which direction? It's going down. So it is a negative correlation. So that means our correlation coefficient is going to have a negative number in it. And then, are they really close together or far apart? Really close together, so it is negative 1. All right, this one.
Coach Sparks, Kim Sparks, please dial extension 221. Kim Sparks, 221.
Excuse that. That was just an announcement over the intercom. I apologize for that, but we're going to keep moving on. Now these are really close together and they're going up, so the correlation coefficient is 1. Now look at this one. I mean, does it have any shape or form or anything? You just have a scatter plot. All the dots are everywhere, all over the place. So that means there's no correlation. So which number represents no correlation? That's right, it is 0. All right, this one, we have negative 0.5. If you look, it looks like it's kind of going down. It's not really close together, so we're estimating in between -1 and 0. Now, looking at scenarios, we're going to look at whether it is a positive, negative, or no correlation. The number of hours you work versus the amount of money in your bank account. It is a positive correlation. The number of hours workers receive safety training versus the number of accidents on the job. Well, if you receive more safety training, hopefully the number of accidents on the job are going down, so that would be a negative correlation. One goes up, the other one goes down. And if you look at example A, if one goes up, the other one goes up, or in the same direction, I'm sorry. All right, the number of students at Hillgrove versus the number of dogs in Atlanta. Well, do they have anything to do with each other? No, so there is no correlation. All right, the number of heaters sold versus the months in order from February to July. Well, you would think that from February to July, the number of heaters sold are going to go down. So it is a negative correlation because the months from February to July is going up in as far as the number of the month that it is. So they're going in opposite directions, so it's negative. The number of rice dishes eaten versus the number of cars on I-75 throughout the day. Do they have anything to do with each other? No, so there's no correlation. And the number of calories burned or lost versus the amount of hours walked. Well, the more walking you do, the more calories you're going to burn. So they're both going in the same direction, so it is a positive correlation. All right, that is the examples. You have classwork that you need to do. Thank you, and have a wonderful day.